Hey smart people, Joe here. I'm about to be one of the first people on earth to eat real chicken grown entirely in a lab. That's right, we're talking the most futuristic nuggets ever. Through those doors, you won't find any real chickens, but you will find a state-of-the-art facility for growing actual meat using biological engineering, not actual animals. The researchers developing this technology think that food like this, cultivated by science, is the way that we'll get many or most of the animal products that we eat in the future. But you're probably wondering one of two things. Why do we need this, and how does it taste?
Humans and meat go way back. As a food source, it's been an essential part of our evolution, both biologically and culturally. But over the past century, thanks to massive population growth and increased demand for meat worldwide, the impacts of farming animals so that we can eat them have become really devastating. Ethically,
air quality so bad.
For our health,
a highly contagious avian flu.
There's a warning tonight from the U.S. Department of Agriculture about raw chicken linked to a potential salmonella outbreak.
And especially for the environment. But some innovative scientists think there's a way to make meat good for us and the planet. Instead of growing it on the farm, growing real meat here in the lab without the animal.
I'm Uma Valeti. I am the co-founder and CEO of Upside Foods, a cultivated meat company based out of California. I was training to be a cardiologist, and during that time, I was exposed to working with stem cells, which are these magical cells in our human body that can become anything. So I was taking stem cells and injecting them into patients' hearts to regrow the heart muscle when they had a heart attack or a cardiac arrest. And I started thinking, what if we can do the same thing with meat? If I take high-quality animal cells and give them high-quality feed and food, they can grow into meat. Our relationship with meat is complicated, but if you step back globally, our relationship with meat has always been about love for an enormously, exquisitely tasty product and not wanting to know how it comes to the table.
Moving meat from the farm to your table uses a lot of resources, especially compared to eating plants. More resource use equals more environmental problems, especially since we're raising 5 times as much meat as we did 50 years ago. And Americans are leading the charge there. Folks in the US eat 149 kilograms of meat per person per year. That's like eating 1,200 quarter pounders. And while Americans love a juicy burger, chicken is king, making up nearly 40% of all the meat that we eat.
There are pockets in which you can produce meat in a very sustainable way that is positive for the environment and positive for climate. But 99% of the meat that comes to our table is produced according to fundamental first principles that do not scale. When you try to raise an animal, you have to feed the animal so it has enough meat on the bone, but the rest of the animal is just a vehicle to get us that meat. No animal was designed just to make meat. An animal was designed to be an animal, love living its life, have babies, heal broken bones, run around, and live as long as it could by feeding itself the food it can find.
One way to think about the environmental cost of raising meat is to look at how efficient the process is. In a perfect, super efficient world, it would take 1 calorie of energy to grow 1 calorie of meat. 1 calorie in, 1 calorie out. But we don't live in that world. For starters, there's a lot of animal we don't eat. Consumers typically go for just a few choice cuts. And depending on the animal, it can take between 6 and 28 calories of energy in the form of feed to create 1 calorie of edible meat. That's kind of like if you bought 28 hamburgers and only ate one of them. Not a great return on investment, especially since we could, hypothetically, take the crops we grow for animals and use them to feed hungry people around the world.
When you have to put in anywhere from 10 to 30 calories of food to make 1 calorie of food, that is an extreme down conversion of energy. So that's problem number 1.
We also have to deal with the gas. Yeah, that kind of gas too.
There's greenhouse gas emissions coming from the animal, whether it's through the burps or the farts. That's the amount of that is intense. And that's an enormous problem that's very difficult to track.
A single cow will burp out about 100 kilograms of methane every year. Add in things like manure, growing feed for livestock, and changes to how we use land, and animal agriculture accounts for more than 13% of global greenhouse gas emissions. If we want to control climate change, scientists agree that we have to get our carnivorous consumption under control quick. Plant-based meat alternatives are having a big moment, But while we're eating slightly less red meat than our parents did, and choosing lower impact meats like chicken more often, the number of people eating plant-based diets hasn't changed much. And the world's richest countries are eating more meat overall.
We keep eating increasing amounts of meat every year, every decade, every century. So that tells me the choice of eating meat is fundamental to who we are as humans. I don't fundamentally believe that we as humans will give up what we love.
That's a take more and more people are beginning to acknowledge. Many believe our species' connection to meat runs too deep to simply erase it from diets altogether. Meat has likely been a part of the human diet since the beginning. Some anthropologists think that our ability to eat calorie-dense animal protein is what let our brains grow so big. Meat is a valuable part of many cultures and traditions too, so getting rid of meat altogether might not happen soon. These scientists think there's a way to keep meat on the menu while making it more efficient and environmentally friendly. And it starts in the lab.
This is what makes it feel like we're in a brewery instead of a meat cultivation facility.
That's right.
So do you just take a chunk of chicken breast and just drop it in, then you get meat?
I wish. That would be a lot easier. We have to go in and isolate the cells we want from a chicken breast or a chicken thigh or what have you. In a rice grain sized biopsy, you're gonna get 10 million cells, and they're gonna be connective tissue, muscle cells, fat, they're gonna be all kinds of cells, stem cells even. So we tease those apart and then we grow them and then characterize which ones grow the fastest, which ones produce the best meat. We literally do like a little competition, and the best ones are the ones that end up out here. The meat you eat is, of course, predominantly muscle tissue, but there's stem cells in there, there's fat cells, there's connective tissue, there's fascia, there's the fibroblasts that glue everything together, there's collagen, there's so many cell types. Interestingly, under the law, no blood can be there, and generally no bone unless you, of course, buy bone in something. And so for us, it was breaking that down to figure out what makes meat tasty, what makes meat meat. And we had to ask that question because no one has asked it really for 12,000 years since we domesticated the cow. This is where we take the food powder that we have and turn it into the food liquid. So we call this feed, simple things we eat every day. Sugars, amino acids, vitamins, minerals, the things you would find in your food. We just blend them in their purified form with deionized water. So there's no bacteria, no viruses. And then this is what the cells both eat and live in.
Is this in a way taking the place of like what blood would do?
It is kind of like that. It's like blood in the sense that it has to carry the oxygen, but the oxygen is not being carried by red blood cells. It's just literally dissolved and pumped into the liquid.
So cells are not muscles and tissues though. So where does it happen that it goes from that mushy cell mix into what we would think of as chicken?
So we're gonna walk up the catwalk. But these are the tissue production cultivators. We invented this sort of technology in order to grow tissue. This was one of the hardest things to do, is to find ways to make cells want to grow effectively as tissues. This is where we rely upon effectively what life on Earth did for us for the last several million billion years. We don't tell the cells what to do at this point. We allow them by giving them a substrate it's attached to. Their evolutionary program kicks on, and they start forming tissues like they would inside of an animal.
So you're just telling the cells, or just letting the cells do what they would normally do?
Right. The only thing we had to do differently up to this point is show them how to swim. They grow floating in a liquid, which is not something they normally do.
Chickens don't swim. I don't think I've ever seen a chicken swim.
Yeah, exactly. Well, that's ducks.
Of course, running a facility like this uses a lot of energy. For cultivated meat to have any real potential, it has to make meat in a less energy-intensive way than using animals. Remember that energy to meat ratio we talked about? To make cultivated chicken better than farm chicken, scientists have to get that way down. And right now, these first-generation factories are pretty energy-intensive. But one advantage they have over farmed animals is how long it takes to grow the final product.
A commercial broiler takes about 6 weeks, which is actually pretty incredible to get to market weight. That's through a lot of selective breeding and great feeding practices. For us to get to chicken tissue, it's 2 weeks or less. In some cases, we can be doing a chicken product every 2 days. This facility is capable of doing about 400,000 pounds of cultivated meat at its maximum.
While growing chicken meat super fast is amazingly cool, it's gotta taste good too. And I'm here to put it to the test.
First one's actually going to be a fried chicken sandwich that we're going to do.
Fried chicken sandwich is, one of the pinnacle chicken items. So I'm pretty excited to taste this one. It looks totally normal. Here goes. I want to give some incredibly scientific
response to this, being a scientist, but like it's a crunchy, normal piece of chicken. It's just striking me like how regular it is. Got the crunch on the outside, like it has like the flavor and juiciness inside. It's just chicken. It's really good. There's two halves here, Eric, but I don't know if you're gonna get the other one. You took the natural biology of how chicken cells have the programming to grow, made them do this so that when I bite into it, I've got no idea that it's just right. I'm glad I didn't eat too big of breakfast. I'm just gonna sit here and enjoy this. This is chicken.
So today we're gonna make for you a pan-seared chicken breast. It's gonna be served with some charred scallions and tomatoes, a little white wine butter sauce, and then we've got some fun garnishes on top for you as well.
Okay, exactly like chicken. Again, remind myself, this is chicken. If you eat chicken, you know it peels apart, like there's texture to it, and this is doing that, and it's kind of blowing my mind. I'm just eating chicken. I know, like I said with the chicken sandwich, I just want there to be this like profound thing, but it's just normal, like playing with my food.
Tasting is a magical moment because you're eating real meat. You know real meat when you taste real meat. And it's almost literally like an explosion of taste buds and billions of senses that are coming together. Because as humans, we know, I think, how to recognize meat. It's hard to quantify by science. It's the art.
I'm kind of a foodie. I like to think I have pretty well-trained taste buds. So I went into this feeling, well, pretty skeptical that this would be anything like meat. And I was wrong. This isn't plant products pretending to be chicken. It really is chicken, just farmed in a totally different way than humans have ever tried. But flavor and taste aren't the only hurdles cultivated meat has to overcome, and not everyone is convinced that it's the solution to meat's environmental problems. For instance, while methane from animal farming is a more potent greenhouse gas than CO2, it doesn't stay in the atmosphere as long. So if a cultivated meat factory gets its energy from fossil fuels, it could have just as bad an impact as the farm it's trying to replace. Growing cells this way also requires highly purified food and nutrients, which are currently much more expensive than what we feed animals. So at least for now, lab-grown meat is considerably more expensive. It can cost between $21 and $236 per kilogram, depending on the type of meat and how it's grown.
So the conventional products that are on the market that are produced with animal agriculture have a definite role to play. The plant-based meat alternatives have a definite role to play. And cultivated meat, which we are growing, has a definite role to play. And increasingly, as we go into the next 5 to 15 to 20 to 50 years, I believe that cultivated meat will have a bigger and a bigger role to play. But it's going to take time for transformative change, because if it was simple to do, we would have done it already. But it's not simple to do, because in the early stages, because there's no roadmap, there's no blueprint, you've got to figure out a lot of these things and bring it together. I mean, if you're talking about the future, let's say kids, grandkids, great-grandkids, and let's say if you're a person who believes in rebirth, the future version of yourself will get really annoyed for not pursuing these choices earlier than we did. They'd be very happy we ultimately made the shift. But I think they would watch for a period in history with horror of what we as humans did for short-term gains that caused enormous downside that we had to dig ourselves out of. But ultimately, I think they'll be grateful that we woke up.
That was an incredible experience. Honestly, I don't know if that is the answer to all of our problems, but I feel like it represents the kind of innovation that it's going to take to get out of this environmental mess that we've created for ourselves. Even though it's something that felt like sci-fi just a few years ago, it's right there on a plate in front of us. I don't know if that is the answer to all our problems, but it feels real, and that feels pretty good. It just tastes like chicken. Stay curious.
Hey smart people, I'm back here in the studio with a few more things for you. First of all, thanks for coming on this curious and rather tasty science adventure today. And to let everyone know that you stuck around to the end, leave a comment with this emoji and let me know, what would it take for you to try meat that's cultivated in a lab instead of grown in an animal? Like, is this the future you've been waiting for, or are you skipping this meal? Since shooting this video, and by the time that you watch it, Upside has gotten the first ever approval from the USDA, this government agency that regulates products like this, to start selling their chicken. bit of coincidental timing, and big news, which means there's a lot of people out there that are wanting to learn more about this like you just did. And there's a few things that you can do to help us reach them. First, make sure that you are subscribed and that you hit that bell to turn on all notifications so that you can be in the early squad. Watch these videos as soon as they come out, which pleases the algorithmic gods and genuinely helps every video get seen by more of the Be Smart community and also reach new curious minds so that we can welcome them into our family. And finally, you can support our work on Patreon. Like these fine people and many others, the support of our patrons helps us make videos for you with our special mix of deep science and fun, entertaining stories. There's a link in the description to learn more, and we'll see you in the next video.
So we're about to look really cool. Shoes covered.
Look at us. Hey! That's right.
It's fashion.